But first, we need to get things started. So if you have your computers, you should open up the Arduino software. So the Arduino software, and it will look something like this. I'm going to share my screen, and I'm going to pick Arduino. I'm going to share that. So it will look something like this. And you're probably not going to have this exact piece of code up, but that's what we need. We're going to start with something blank. So I'm actually going to start with a new sketch. And an Arduino program, so Arduino is both the hardware that's in front of you, but it's also the software. So we're writing software that runs on hardware. It's called firmware, technically. And it comes in two pieces. There's void setup and void loop. And you can see here with comments, setup code goes here inside of these curly brackets, technically called braces, but I like calling them curly brackets. And void loop. Our void setup code will run once and only once when we power on the Arduino or when we first upload code. Void loop is just what it does. It says it will loop over and over and over and over and over again. So that's the difference between these two functions. And any code we write, for the most part, will go inside of these two things. There's always exceptions to the rule. Can't see my screen. Odd. Sharing my screen. Oh, because I'm sharing this window. Here, I'll do this. There. Everybody see this now? Perfect. Sorry, I opened up a separate window and it didn't follow me. So again, void setup at the very top runs once and only once, and void loop runs multiple times over and over again, very, very fast. So we're going to, you can see if you're, first of all, I want you to plug in your Arduino. So you're going to take, if you can see my screen at the top, you're going to take your USB cable and plug it in to your breadboard, and then plug the other end into your USB port. And I'm hoping, I saw that the link come up earlier about the hookup guide. If hopefully you haven't had a chance, you need to follow that link in terms of getting drivers installed and things like that up and running. So I'm on a Windows computer, so if you're on a Mac, it'll look a little different than mine. But what we're going to do is we're going to go Tools, Board, and you're going to select your SparkFun AVR boards, SparkFun Red board. So you're not going to have a bunch of these choices that I have, but you should have SparkFun AVR boards, Red board. If you don't, that's okay. You should be able to go to Arduino AVR boards and just use Arduino Uno. But SparkFun AVR Red board. You should then be able to select a serial port or a COM port. So I'm on Windows, so it will say COM and then a number. So I have COM 20. A Mac will be /TTY or dev/TTY/ and then a bunch of letters and numbers. If you have multiple serial ports, because this happens sometimes on Windows especially, pick the highest number one. So Arduino will always enumerate as the higher one. But you can always unplug your Arduino, double check what ports show up, and then plug it back in and compare which one's which. So I'm on COM 20. So I'm good to go, and I'm gonna start writing some code. So now to control pin 13, that LED, that blue LED, we need to write some code. And what we're essentially doing, and speaking in metaphors, is that we're going to build some roads first before we drive. So we drive or we control pins, but we have to build roads for those pins to drive on. So we have to tell the microcontroller, is that pin going to be an input or output, and how are we going to use it? And then we can go ahead and use it once we tell the microcontroller what it's being done. So we tell the microcontroller in setup how we're going to use it by a command called pin mode. Notice how I typed that. So I'm gonna actually delete it, and I'm gonna type it again. Pin capital M ODE, parentheses, open and closed, and then a semicolon. If you type this correctly, pin mode will turn orange. And then inside of the parentheses, I'm going to put two values. The number 13, and then the direction we're going to use the pin, which is an output. So how are we going to use this pin? We're going to use pin 13 as an output. From this point, we can now, in our loop, write some code. We can actually go in and use that pin. So we're going to say digital write. Again, open close parentheses first, and then I'm going to go back in and say 13 high. Digital write with a capital W. Again, it turns orange if I do it correctly. Which pin do I use? Am I using? 13. And then the state that I want it in. High means on. So think of a light switch. If I flip a light switch up or high, normally it turns on. If I flip a light switch down or low, that light switch turns off. And since our LED is blinking, this is going to be our first piece of code. We're just going to have it turn on. What I'm going to do is I'm going to click, there's a check mark, which is called it's verify. So if I want to, it's like spell checking for code. If I want to verify this, I can click the checkbox, or I can just upload. Well, in Arduino, when I click the upload button, it verifies it anyways. So I'm just going to click upload, and it will compile my sketch. What compiling is that it's turning this relatively human-readable programming language into ones and zeros. And it's checking for errors and making sure everything works. And then you can see the progress bar here. And then it will start to upload. And you'll start to see the RX and TX LEDs blink on your breadboard. That means that code is going to the breadboard itself. They'll blink a little bit, and then your blue LED on pin 13 should be on and just stay on. It shouldn't blink anymore. So Luke, if you go to Tools, Boards, if you don't have a SparkFun option, go to Arduino AVR boards and Arduino Uno. Works the same way. I'm going to give everybody a little bit of time just to make sure that everybody's able to get that LED up and running. A little bit about some of the wording here. So digital is something that's on and off for a 1 and 0. When we see something that's digital, it's going to be, there's only 2 states to that command or function. When you see write, that's going to be an output. So writing, just like when we're in school, if we're going to output something, we're going to write it. If we're going to, it's an input, it's going to be read. That's us actually reading something. So when you're looking at code, if it's digital write, it's going to be an output, or anytime it's a write, it's going to be an output. If it's a read, it will be an input. The opposite of digital is analog. So we have digital write and read, and analog write and read later on. Okay. We're going to work towards getting this back to blinking now. So I'm going to add to this. So I just hit enter. I'm on line 9. You don't have to be, but just underneath the digital write, I'm going to type delay 1000. Delay means this is a stop sign. And wait for 1000 milliseconds. So this is in milliseconds. And then digital write again to 13. Low. Low meaning off. Light switch down. And then we're going to hit delay 1000 again. So what we've done, if I go to the top of the void loop, is we turn the LED on, we wait 1 second. We turn the LED off with digital write low, and then we wait 1 second, and then we go back to the top. We turn it on and wait a second. So now it's going to go back to blinking. The delays are really important, and here's why, is that the Arduino, the microcontroller that you have in front of you, can do thousands of lines of code per second. So fast that if I just had digital writes on off, you wouldn't actually see the LED turning on and off. So we actually have to tell the microcontroller to slow down. So with that being finished, we're actually going to go and upload again. I'm going to hold up my breadboard so you can see. So again, it's compiling. And when it's done compiling, you'll start to see my LEDs blink really quickly. They're yellow and orange. They might not show up in this lighting. Compiling, and then you'll see it blink, and that was the code going on, and now it's blinking again. Yay! Now that you have it blinking, what I want you to do, snag your dangerous bag of LEDs, empty them out, and pick your favorite color that you have in front of you. I'm going to pick red. I work for a company that is really red. So, and the LED, it's probably easier if I show this on a different screen. So I'm going to stop sharing this really quickly. And I'm going to share a different window. It's called Fritzing. And this is cartoons for electronics. This is an LED, and yours actually looks like this. So there's a couple of things to note about an LED. This only works one way. It's called a polarized component. Current or electricity can flow through it only one way. And so the length of the leg notates which one's ground and what's one positive and negative. Easiest way to remember that, if I'm long on patience, is that it's a positive quality. If I'm short on patience, it's a negative quality. So the long leg is positive. It's always going to go towards this source of positive. The short one is always going to go towards ground. we're going to build our first circuit without actually using this breadboard. So we're going to move the breadboard over. We're going to take the LED. I should have flipped it the other way. There. And you're going to make sure that you have find the long leg and the short leg, and you're going to put the long leg so that it's going into pin 13. The short leg will go into ground. Once you do that, and I'll do that right now, something magical will happen. My LED is now blinking. So you've built your first circuit, and notice that now my pin 13 on my board is no longer blinking. It's hard to see with the bright red, but the blue one isn't blinking anymore, and when I take this out, it will start blinking again. So you can think of these, the pins on the Arduino as kind of like a power strip for plugins. I can plug things in and out, but I only have certain pins can be used certain ways. Okay. Now, how to use this thing called a breadboard. So we only have 1, 2, 3 ground pins on the whole Arduino board, or the red board. That's fine when I have one LED that I want to control, but what happens if I want to control something on pin 8? I could kind of maybe bend the legs and have this stretch across here, but ultimately we want to be able to build something that has a little bit more complexity to it. So we have to use the breadboard, and I'm going to pull this LED out. And I'm actually going to rotate it and flip it so that the long leg is like that. So I want everybody to take two jumper wires, and they're all in different colors. So let's pull from the side that has black. Peel 2 of them off. You can leave them together, you can have them individual, but I kept these together. It keeps them nice and organized. So I have a black and a white. Now I'm going to take this LED and I'm going to put it in the breadboard so that each leg has its own row. And the long leg is in a row away from me. So imagine that I'm sitting at a desk and this breadboard and our red board are towards me here, and then this is away from me. So I have up towards the letters here, I have the long leg in one row and the short leg in the other row. And we're going to talk about rows and columns here in a second, but just insert it like so. Now I have a white wire and a black wire. Black wire is going to go from the same row as the short leg to ground. And I'm going to make these nice 90-degree corners, and I'm going to change the color to black. And I got myself in trouble because I picked a white wire and it's a white background. So it will be a different color. So and then I'm going to plug the white wire into pin 13, and then the other end into the same as the long leg of the LED. I'm going to make it blue, not red, so that it's visible and not white. And I'm actually going to do that on my camera. I'm going to go to overhead. So black from ground to the short leg. And it can be any pin in that row. And then white to pin 13. Now I have my LED blinking. So now I have space. I can separate these out. They can kind of move around. And I have a lot more space to work on my breadboard than I do on top of my red board here. So that's your first breadboard circuit. And this is how a breadboard works. So where you see that there's numbers and letters here, this is called the field. And it's split into two. So there's a ditch down the middle, and there's left and right. And these holes, these are connected by row. So A1 and E1 are connected electronically underneath this plastic. A10 and E10 are connected, but they're not connected across the ditch. So F10 and J10 are connected, but they're not connected to A10 in any way. So there's no electrical connection from left to right in the field. These areas on the left and the right are your power strips. They're connected vertically along your breadboard. So this one at the bottom, negative, and the one at the top, negative, are connected. Vertically on the red are connected all the way down. Even though there's these gaps between them, they're still connected all the way down. At least on the breadboards that you have in front of you. With that being said, just like when we take a power strip and we turn one outlet into many, we're going to do the same thing for ground right now. Since we only have 3 grounds on the whole red board, we're actually going to take one ground and turn it to about 25. So this end of this wire, we're actually going to take it out of this row and we're going to plug it in to this ground column here. Your LED should have stopped blinking. It's a good thing if it did. And then we're going to grab another wire. It doesn't need to be black. I know that there's like a rainbow of colors, so you can just grab another wire. So for example, I have yellow. I'm going to peel off my yellow. I'm going to move my black to ground here. And then I'm going to use a yellow wire to then connect that where I just removed the black wire to ground. And I'll do that here as well. I'm going to leave it on the cartoon. I'm going to leave it black so that you can see that it's ground. Why did we do this? It's so that I now have 25 grounds rather than just one. Not showing up there's all there says is COM5 and COM6. So your Arduino should be connected to COM6, Luke. Yep. So select COM6 and then try to upload some code. Yeah. Actually go to File, Examples. Here, I'll type it in here for you. So File, best thing to do right now, File, Examples, Basics, Blink. And then change the delay numbers to something else, like 500. Perfect. So there's my LED. Now, what we did is we set ourselves up so that we can add another LED. So I'm actually going to go find another LED. I'm going to copy this one. I'm going to paste it. So go find another LED. It can be the same color or a different color. It doesn't matter. I'm going to place it close to, but not right next to it. Give it some space. I'm going to grab 2 more wires. So I'm going to do that here as well. Again, with the long leg towards the top. And I'm going to grab 2 more wires. My wires are going to be purple and gray this time. I'm going to use gray as my positive and purple as my negative because it's close to black. And I can plug in the purple into the ground rail. And then I'm going to plug the gray into pin, let's do pin, we're not going to do 12, we'll do 11. So a long leg goes to pin 11. Do wire color, let's do green. And then a black wire to ground again. Now this LED should not be blinking. Shouldn't be doing anything because we haven't told it to do anything yet. So I'm going to wait for a second so everybody gets this. And then I'm going to go back to code here in a second. So I'm back to blink. So we added an LED to pin 11. So I have to add a pin mode for pin 11. So I'm going to say pin mode 11 output. Because it's another LED, it's going to be an output. What we're going to do is we're going to create railroad crossing. We're going to create when one LED is on, the other LED is off. So it's going to blink back and forth like this. So when digital write 13 is high, we want digital write 11 low. And then when 13 is low, we want digital write 11, the opposite, which is high. And I'm going to upload that to my breadboard. And we're going to see if I made a railroad crossing here. So it's still blinking. I might have to wait until it's done compiling, and then it's going to upload. And see back and forth. One turns off and one turns on. One of my when I was a teacher, one of the favorite things to do was students would bring in toy cars, and especially toy police cars or fire trucks, and we would add LEDs so that their lights actually worked. So that was one of their projects to do. Or if they brought in a toy robot, we'd make their eyes blink and all that stuff. Hey, Luke, try unplugging your breadboard and then looking at your COM list again and see if either one of those have disappeared. So with this blinking, right, the delay number stays the same the whole time. We can't change it. But we can with reading a sensor of some kind. So we're going to add our first sensor. And I'm looking at the sensors we have available to us, and we'll use a light sensor, which is this guy. And we're going to need a resistor. So of these things, these little whiskery looking guys, we have 330 ohm, which is orange, orange, brown, and 10K, which is orange, black, brown, correct? No, brown, black, orange, if I remember. Brown, black, orange. We want the 10K, the one with the green text. So we want one of those. And this is way more fun in person, but I have to do it all the time anyways. So I'm going to switch to my camera. So with these resistors, their legs stick straight out. So we have to bend them down. So how I do that in an efficient way, in a way that I don't mangle the legs, is that I hold the little pill-looking part between two fingers. And then I just take my fingers and I slide them down and bend it over and make a noise. Whoop! And go from there. So now I have a resistor that has legs that point down. And you should have the light sensor, which has really long legs. And we're going to build this circuit in Fritzing here as well. And we're going to build a circuit that's called a voltage divider. Not going to get into why it's called a voltage divider and all that stuff. But that's just what it is. You guys can look it up later if you're really curious. But I'm going to grab a resistor, and I'm going to change the colors of that so it's correct in a second. And I'm going to grab our light sensor, and I'm going to make his legs a little longer here. And this is 10K. So brown, black, orange. I'm going to rotate this. We're going to put our light sensor circuit towards the bottom of the breadboard. So we're going to take our resistor, and we're going to make sure that each leg is in its own row. Like so. And then I'm going to take my light sensor. This is a little bit of a complicated circuit because it's going to share a row with one end of the resistor and then have its own. So you should have 3 rows down here that are populated. One end of the resistor, a middle row, which is shared by the light sensor and the resistor, and then one leg of the light sensor should be by itself. Okay. You're going to need 3 wires now. 3 wires. Preferably if you have one that's red, one that's
Derek?
black. Yep.
Are you showing us something in Fritzing?
Yeah.
So we're not seeing it.
Odd. Okay.
We're still seeing the IDE code.
Huh. Okay. Let me stop sharing. I'm sorry. Thank you for speaking up. Okay. How about now?
Looks great.
Perfect. So I'm sorry. Now I will start over again here. So you have resistor, light sensor. So the resistor here, 10K resistor, is in the breadboard so that its legs, and we're at the bottom of the breadboard. The light sensor and the resistor are sharing this center row here. They're not in the same hole, they're in the same row. And then either end has its own row like that. Now it's time to grab 3 wires. And we're going to put voltage or a supply, a power on one, ground on the other, and the other one's going to be our signal pin. So I'm going to take a wire that's going to go from 5 volts or 5V over here all the way to the far end of the light sensor. At the far end or the loose end of the resistor, I'm going to have a black wire, a ground wire, that goes from ground to that end of the resistor. Lastly, we're going to have our third wire go from this shared middle row to this pin over here that's called A0. Ooh. I'm going to make that orange. No, it looks too much like red. Cyan, sure. Perfect. So now the wiring for the light sensor is done. I know it seems complicated. We went from blinking some LEDs to a light sensor, but that's where we're at. Okay, so now what we need to do is that we are going to go back to code. I'm going to make sure that I'm sharing my screen appropriately this time. So everybody should be seeing Arduino code again. Thank you. Now, we're going to say we're using special pins with A0, but we can still make it an input. So we're going to say pin mode A0. That's an A0, not an AO. Input. And instead of this 1000, we're going to say, we're actually going to put a function inside of a function here. Analog read A0. And same thing for this delay. I know it's kind of funky. You know what? We're going to do this right. I apologize. We're going to create a variable because that's the right way to do this, and we're going to do it the right way. So to create a variable, and a variable is basically, think of it as a bucket we can store numbers in. And that's what we're going to do. We're going to store a number. So we're going to say int or integer. An integer is a whole number. We're going to call it value. We'll just call it val. Equals analog read A0. And then instead of delay, I'm going to put val in here. Sorry for the switcheroo. So void loop. So what we've done, we've set up A0 as an input, int val. So we're going to, every time it comes to the top of our loop, we're actually going to read the analog value. Remember, analog is not 1 or 0. It is a range of numbers. And in this case, analog read is a number between 0 and 1023. 0, in the way we have our circuit built, 0 is completely dark. 1023 is completely bright. The room you're in may fall somewhere in between. 255, 512, something. We'll write 13 high, 11 low for whatever the amount of milliseconds analog read comes back at. So if it's super bright outside, it will be about 1 second about what, or inside. If it's really bright, it'll be about what your LEDs are doing now. And then as it gets darker, that will slow down. It'll get faster. So it'll become a dance party. And then as it gets brighter, it will. So when we finally get our code, you can put your hand over it, and those LEDs will blink faster. So let's see if we got it right. So I'm going to upload this. Wire my circuit. Zero, 5. Okay, cool. So your blinking should change speed. There is. We're going to go through that next, Matthew. You're reading my mind. So the question is, if you're not looking in the chat, Matthew asks, is there a way to see this? There is. And so we're actually going to use what's called the serial terminal. It does take a little bit of extra code. So in our setup I like to put it at the very top. I like to say serial.begin. And inside of begin, I'm going to put 9600. It's just how fast our serial port's going to communicate. But it's just important that it's 9600 for now. Different devices communicate at different speeds, different amounts of data. And then underneath our int val with this spot that I left open, we can say serial.print ln, so it's an L, print line, val. Notice that the S is capitalized in serial. I'm actually going to give it kind of its own line here. So we're going to read the sensor, store it in val. We're going to look at val in terms of our serial port. We'll get there, how to view it later. And then the two delay values are val. with that, I'm going to upload the code because even though we changed the code, so every time we change it, we have to upload it. And this is going to get tricky. I need to remember that it's going to, my serial port is going to open I'm going to open a new window, so it'll take a second for you to view this. I'll have to change what I'm sharing. So I'm uploading this. And now what I'm going to do, I'm going to open my serial monitor. And I'm going to be right back. I'm going to stop sharing and reshare my serial monitor. So you can see in mine, so it's the little magnifying glass in the upper right-hand corner of Arduino is your serial monitor. And I have my serial monitor time-stamped with this arrow and stuff. Yours might just be a list of numbers. That's okay. I have these on just so that I can visualize things for my work. But right now I'm getting about an 890, about 900 value. If I put my finger over this, it goes down to about 622, 624. Part of this is we have bright red LEDs blinking next to it. So if I put my hand between the LEDs and the light sensor and then put my thumb over the top, you can see that it goes up to 400-ish. And the LEDs blink a lot faster. And then when I let my hand off, it's about 900 again. So again, darken it.